All right, so let's see how we can extract the question time data from the video which we recorded. Now, this is the video which I had to re-record because for certain reasons. The video now, before we begin to analyze or extract the data from this video, there are certain initial steps which you have to do. And the first and foremost step being defining the coordinate axis. So, as we just saw, this pink uh, icon helps us to define the axis. So let me just zoom in to show you the axis, right? So I've ensured that the zero of the axis is positioned right at the ball, which means the ball is at the zero mark. And as usual, the x-axis is along the horizontal direction and the y-axis along the vertical direction. X-axis positive on the right and negative on the left, y-axis positive top and negative at the bottom. So which means the ball is actually dropping in the negative y-axis. That's first step. Now I can click the same button again to make the axis disappear. Now I have one more important point to do, which is called as calibration. Now hope you I realize the fact that this is a scaled down version of the true self. So which means you have to tell the system a yardstick so that it can convert it into the actual scale. So I'm going to use the calibration stick. So as I told you, this length is actually 200 centimeter. So I'll have to zoom out a bit to ensure that these 2 points are in line. So let me mark it somewhere here. So now I have to zoom in to check whether it's right. Yes, it's right. So yeah, so there is definitely going to be some source of error, which in this case, which I don't think we can eliminate completely. So as I told you, that's 2 meter in length. So that's the second step which we have to do. And what we can do is we can lock the calibration stick and we can make it disappear. Now the third step which we have to do is we should check uh, the frame rate of the video. The frame rate is important again because it's the frame rate which decides the time interval of one particular frame, based on which the data is collected from the video. So the frame rate at which the video was recorded was 30 frames per second, which is right here. So you have to ensure that the frame rate at which the video is recorded and the frame rate which you see here are the same. The film icon over here will help us to do that. And the last step is that now this video has got lots of frames in it, and I'm not going to drop the ball right at the first frame. So what I have to do is I have to first find the frame at which the ball is just leaving my hand, and I have to make that frame the first frame of analysis. So I'm going to find that frame now. I'm going frame by frame to find that frame. Yes, that's the frame. That's the frame. So as I see, I'm going to set this to 0. So now we are done. We have done with all the initial steps necessary to analyze the video. Now what I have to do is I have to create a point mass, and I'm going to change the color so that it's visible to us. Right. Now what's the advantage of this tool is we can actually auto track the video using a few click of buttons. Now you should also realize the fact that this software works based on looking for certain combinations of pixels from one frame to another. So I have to tell the system what pixels does it look for. So I'm going to use shift command in Mac, and whereas when it comes to Windows, it will be control shift. So I'm holding command shift now, and if I click the ball, right, as you see, what the system is going to do now is it's going to look for this particular template in all frames. So all I have to do is ask the system to look for such kind of frames one frame at a time. So as you see, the software is able to identify the track the ball basically. So I'm going to track the ball as long as the system can do, but at certain points the system will not be. So you'll have to make some corrections then. Now over here, the Windows color and the color of the board are almost the same. So maybe the system is not able to track the ball. So what I'm going to do is I'm going to just delete this point. I'm going to tell the system to track the ball again. So search next again. So it's happening now. Let me scroll down. Yeah. Search next. Search next. Search next. Search next. Right. Um, so the last frame is a tricky because there is a good chance that the ball has bounced back from the surface. So I have to ignore the last frame as of now. Now let's quickly zoom out and see. Now you can very clearly see that the distance the ball has traveled is actually increasing with time. All right. Now what we'll do is we will look at the graph. So we'll have to make this as y-axis. Remember I told you the ball is actually traveling in the y-axis. So y. You see the graph now, guys? You see the graph? You see the graph? This graph clearly must remind you of something, but it is in the fourth quadrant because of the fact that y is negative downwards. So to avoid any confusion, what I'm going to do is I'm going to rotate the axis such that the y value becomes, okay, I'm struggling. I just wanted to ensure that this is 180 degree, right? Now you see the y is positive, which means the ball is actually moving in the positive axis now.